So I set out to build a classic game Snake with all of the major releases of Python. That's Python 0.9.1, 1.6.0, 2.7.18, and finally 3.14. But why? Well, Python has been around since 1991 and has since become one of the world's most popular programming languages. And with every Python release, there has come a ton of new features and improvements. However, I only know a sliver of that because I've only ever used Python 3. So I started to wonder, what was Python like before version 3? And more importantly, what was the developer experience like when building software using Python? So I figured, what better way of seeing that than actually building something with all major releases of Python? That is, assuming I can even install these older versions of Python. The Python website literally calls Python 0.9 ancient. But there's another catch. I have to do this following a few rules. First of all, I can't use any external libraries. The goal of this project is seeing what it's like actually using older versions of Python and not some library. So that means that things like Pygame are just out of the question. The second rule is really just to make my life easier. Honestly, at this point, I don't know if I'm even going to be able to install these older versions of Python. I have a suspicion that I'm going to need to install this in some weird environments where I might not even have graphical interfaces. So because of that, the second rule is that this has to be a CLI application that I can run in a shell. However, this should also allow me to do something kind of interesting. By making the program as portable as possible, I should be able to just take the code from the previous Python version and put it in an older Python version and then see how the language has changed over time. My hope is that I can just copy and paste code from one Python version to another and then it will somehow magically work. But let's face it, that's probably not gonna happen here. So with that in mind, let's start off with Python 3. Now, I'll be the first to admit it here that I think I kind of over-engineered this program, but that was very intentional. My goal was to cram in as many features that I think might be more modern to see how things change later on when we use the same features in older Python versions. So for example, I use things like pattern matching and assignment expressions, which I think are features that some people don't even know exist in Python. And just so that we're all on the same page, let me quickly run you through the code. So to start off, let's look at the main entry point. The main game loop is wrapped around curses so that we have a more interactive experience because again, this is a CLI application. So let's look at the game loop. Here we have this no delay statement, which makes it so that our loop is non-blocking. And then we have some variables over here and we start our loop. In our loop here, we have this renderable function, which renders a frame for our game that puts the snake, the board, and the food, everything together in one single place, and then returns that. Then next we have this direction, which we use to get the direction as input from a user and then turn that into an enum, where the enum is all of the directions up, down, left, right that correspond to the arrow keys on the keyboard. Then we have this move function that lets us move the snake to a specific direction. So if we look at that, what we actually do here is we mutate the current snake list into a new snake list so that we have the new board to render later on. Following that, we have some simple logic so that moving in the opposite direction in which the current snake is not traveling in does not result in you losing the game, essentially in a collision. Next, we have this if statement in which if the head ever collides with a food point, then we go ahead and add a point to the snake. This just takes the snake list and appends a new item to the end of the snake. Following that, we also increment the score by 10 points. And then finally, if the head of the snake ever collides with any other part of the snake, we deem that as a loss. And then finally down here, this is where we actually print the current frame, where we format the board string, which essentially just puts everything together into a single string. That is the score and the current board. After that, we refresh the current frame and then sleep a little bit until the next iteration. And then finally, if the user ever lost, that means we got out of the loop. We return both the board and the score so we can go ahead and print those later on for the user to see, and we let them know that they lost. And now to actually run the program, we can do so using a Python 3.14 interpreter. We'll run Snake, and here's our game. Just like that, we have Snake up and working, and it's actually quite fun to play as well, which is fantastic. So now let's move over to Python 2.7.18. Now, installing Python 2 was really easy because I run Arch, by the way, so I was able to install Python 2 from the AUR really easily. I then copied over the code for Python 3 into a new file and ran the program using a Python 2 interpreter. And upon running the program, the first thing I lost was type hinting, which honestly is not that big of a deal considering that even in Python 3, type hints are optional. So I went ahead and removed all of the type hinting. After that, I lost f-strings, which is one of the ways you do string interpolation in Python to easily combine multiple values as a single string value. To get around this, I chose to use the format string method instead, which works very similarly, but it's just a little more verbose, requiring keyword arguments for the values to interpolate. And then for other things, I also used the plus operator as a way to combine strings. Next, we lost pattern matching, which was expected as this is a pretty new feature. Pattern matching is essentially how we do switch statements in Python, which for the longest time, this was actually a missing feature in the language. Before match expressions, a common way to mimic switch statements is using dictionaries by storing the case in a key and the outcomes as a value. So that's what I did here to keep similar functionality. Not surprisingly, we also lost assignment expressions next. Assignment expressions are a shorthand way of assigning a value within an expression. This allows you to do fancy things like assigning a value to a variable inside of an if statement block, while being able to use that same variable in that same block. And so because that is what I was doing here, the obvious thing was just to assign the variable outside of the if statement before using it inside of the if statement. And just like that, Snake was up and running again, or so I thought. You see, up until now, I had been working on my laptop. Later, I tried running the same program on my desktop computer with a fresh install of Python 2, and I noticed that enums are also not available in Python 2. Later, I learned that even though enums are not available in Python 2, there is a compatibility package to enable enums in Python 2, which is probably what I had installed on my laptop. So to fix this, I replaced enums with constants, and now this time we were really done. Now, let's move on to Python 1.6.0. But first, we have to install it, and unlike Python 2, Python 1 is not in the AUR, which is honestly kind of funny. If you're familiar with Arch Linux, then you know that you can find pretty much every program under the sun in the AUR, and that's actually one of the primary reasons I run Arch, because the AUR is really good. So I finally found a program that is not in the AUR. So I did the next obvious thing and downloaded the Python source from the Python website to attempt to compile it. But then I got this error, which as far as I understand, tells me that my GCC compiler is not able to create executables, but that is strange to me because I have definitely compiled executables on this machine before. So after researching online and not being able to find anything concrete, I figured, well, Python 1 is pretty old, so maybe I just need an older compiler. So I tried the oldest Docker GCC image that I could run on my machine, which was GCC 4.9.4, and I mounted the Python 1 source code to it. And it just worked. That was really surprising because in my experience compiling source code, especially for older programs, it doesn't always go super smooth. Also, as a side note, I found out that I was also able to use this GCC Docker image to compile all of the Python versions from Python 3.14 all the way down to 0.9.1. After copying over the Python 2 source code and running it with the Python 1 interpreter, we lost sets and list comprehensions. Comprehensions are syntactic sugar that lets us both iterate sequences and assign the results of those iterations in a single line. But of course, we can do the same thing with a more traditional loop syntax. Next, we lost the plus equals operator. So I just worked around that by concatenating values using the plus operator and assigning the result back to the variable I want to concatenate to. Then we lost ternary operators for single line Boolean expressions, which just means that we need to do things in more than one line. And then at this point, I hit my first real problem because the curses module didn't exist. So my solution here was to use a combination of the input function and print statements, and then using threading to achieve the same level of interactivity that we had. So I began doing that by first doing the easy things and replacing the input statements and print statements, which then allowed the program to proceed. This is when I learned that in Python 1, the print statement no longer follows the same function call syntax. Surprisingly though, we also lost sets. So at the detriment of losing a bit of performance for fast lookups, I opted for using lists instead. Also, surprisingly, we also lost Boolean values. I definitely was not expecting that because Boolean values are a pretty basic data type. The good thing is that we can still use integer values for booleans and that still worked. So I replaced all false values with zeros and all true values with 1. Next, we also lost the copy method for lists, but I found that slicing still worked as a way to copy lists, which is pretty cool. This is the kind of syntactic sugar I wouldn't expect to exist in older versions of Python. We also lost the format string function, and after all of that, we finally had a working game. But I still needed to implement the threading part that I missed before to try and keep the same level of interactivity. And that's when I noticed something interesting. If you remember from before, the cursors module was not found. But look at this. For some reason, when I tried importing the cursors module in a Python 1 interpreter, the import failed, but only the first time, which led me to believe that the module did in fact exist. And after looking at the lib section for the source code, I confirmed that yes, the cursors module did in fact exist. So then why was the import failing? I spent some time looking around the source code and I found this. As it turns out, Python 1 does support cursors, but it's disabled by default. In order to enable it, I had to uncomment this line and then recompile Python. And just like that, after the compilation was done, importing the module worked. So after that, I was able to put in the cursors part back into the program, and just like that, we had a working snake game in Python 1.6.0. So now we get to Python 0.9.1, and I've been really curious this entire time to see how this is gonna play out. So, like the previous programs, I copied over the code from Python 1.6.0 and tried to run the program using the Python 0.9 interpreter. The first thing we lost was triple quotes for docstrings, so I just chose to remove them. Next, I saw this message, which initially made me think that we lost a new line character, but that didn't make too much sense to me since I'm pretty sure that this convention supersedes even the oldest version of Python. So I looked at the Python 0.9.1 docs, which were included in the source code, and that's how I learned that yes, the new line character was in fact not the problem, but rather it was the double quotes. From the examples I saw in the docs, I learned that in Python 0.9, strings are exclusively written using single quotes, which I know also works in newer versions of Python. Next, we also lost default function arguments. I didn't find any way of doing this from the Python 0.9 docs, so I chose to remove them. And then I saw this, which at first didn't make sense to me as it looks like the error pointer is pointing at nothing. And after thinking about it for a bit, I realized that it could just be a problem with empty spaces. So I made a change to remove the empty space, and yeah, that was it. Apparently, you can't have empty spaces in blocks, which is honestly not great for code organization. So what I did is I just removed all the empty lines. Next, there was an issue with dictionaries, which initially I thought was another spacing issue, but after removing the spaces, I realized that wasn't the issue. Looking at the docs, I learned that in Python 0.9, dictionaries can't be initialized with values. First, you need to create the dictionary and then add values to the dictionary. Then I found more spacing issues. As it turns out, you can't have new line breaks in function signatures or inline expressions that are wrapped in parentheses. Next, we lost inline Boolean expressions that save Boolean results in a variable. This just means that we have a little more repetition because we need to rewrite conditional logic in if statements. Now, this next one was interesting because there was an error with the equality operator. After looking at the Python 0 docs, I learned that the equality operator is actually a single equal sign, which in my opinion is kind of confusing, but the Python docs do mention how this ambiguity is resolved. Additionally, there also isn't a not equal to operator. Luckily, we can negate using the not keyword. And then we hit this again. The cursors module didn't exist, but we have seen this before. So I tried to apply my knowledge hoping that all I had to do was enable the cursors feature and then recompile. Unfortunately though, looking at the source code for Python 0, this time the module really didn't exist. Also, it doesn't look like any sort of threading exists either. But while I was looking around at the source code, I did see this. As it turns out, even Python 0.9 has support for glib, which means that this really didn't have to be a CLI application after all, and I could have added some graphics to this. So given that this version of Python doesn't have any support for cursors or threading, I chose to make this a little less interactive by using a combination of raw inputs and print statements instead of building that functionality myself. After making those changes, I also noticed that the random library didn't exist. But looking at the docs, I found out that this did exist, but it was just called rand instead of random. But then I ran into an integer overflow error, which is pretty funny when you think about it, because this is extremely uncommon in modern versions of Python, and maybe even impossible. Looking at the source code, I could not see any obvious places where this was happening. I thought it could be because the random seed was created using the current date, and we are now much further along than 1991, which was when this version of Python was released. So that would mean that this is now a bigger number, and this could be overflowing because of that reason. So at one point, I tried setting the seed value to a date back in 1991, but that didn't work. What I ended up doing instead was just replacing the multiplication with addition to make the numbers much smaller, and then recompiling Python, which I know probably isn't the optimal solution, but given that I was running out of time for this project, I called it good enough. And also look at this. Remember how spaces weren't allowed in Python 0.9? Well, if we look at the source code for this random module, you can see that they actually did spaces by using comments. So spaces are just empty comments. We also lost sys.version, so I hard-coded the version value instead. Then we lost the list remove function, so I wrote my own. Then at some point, my program finally started working. But we did hit our first runtime exception because the dictionary get method is now gone. The good thing is that I already had some logic to prevent accessing unknown keys, so I was able to convert these get statements to use the bracket syntax. Then we lost the ability to typecast integers into strings for string concatenation. After looking around for quite a while, I couldn't find a way to convert integers to strings with built-in functionality, so I ended up writing my own function for that. I have done this sort of thing before in languages like assembly, where I also didn't have access to such functionality. The function is pretty straightforward. All it does is recursively mod a number by 10 to get the last digit, get the string representation of that digit, and then divide the entire number by 10 to drop the last digit until we reach 0, which means that there are no more numbers to convert. Next, we lost negative indexing, which was also an easy fix. All we have to do was compute the index we want to access. And some very small tweaks later, we now have Snake on Python 0.9.1. I did notice something a little bit strange though. For some reason, the score is stuck at the top of the screen, even though the string concatenation does not happen in that order. The Python version should be printed first and then the score. I looked around for a bit to see what could be causing this, but nothing stood out. Unless I am doing something strange here, maybe this is just a bug in Python 0.9.1. Regardless, I'll have a link to the source code for all of the Python versions in the description in case you're curious to see the code yourself. And maybe someone else can figure it out or just reassure me that I'm not going crazy here and confirm that this is just a bug. So now back to our question. What was working with older versions of Python like? Honestly, I'm pleasantly surprised. The older versions of Python didn't change the language all that much, and it's almost like the developer knew exactly the direction they wanted to go when building Python because it's all very similar. It's even surprising that features like slicing still work in older versions of Python. Slicing actually works in version 0.9, which is kind of surprising. That seems like a feature that would have been added way later on to make the language easier to use with all the syntactical sugar, but it still works. And so even as someone who hasn't used Python 0.9 before, I knew how to use it and I knew how to work around its limitations, which means that the developer experience really has not changed all that much. It's stayed the same. And if you like that video, I think YouTube thinks that you might also like some of these videos over here. Go watch those.